Welcome to the lesson on the unique features of battery electric vehicles, BEVs, and their diagnosis using onboard diagnostics, OBD. In this lesson, we will address the role of OBD2 in diagnosing and resolving issues within a car's system. Let us look at our lesson objectives. By the end of this lesson, you will be able to identify and describe the unique BEV features that onboard diagnostics can diagnose. The computers or modules in BEVs are primarily responsible for monitoring and reporting the performance of various vehicle systems and detecting malfunctions. The OBD gathers information from the different computers or modules in the BEVs, relaying the information to the technician when an issue or performance problem is detected. The OBD is a standardized system that helps ensure vehicles are running efficiently. In this lesson, we will explore the unique features of BEVs, namely one-pedal driving, instant start, pedestrian alert system, propulsion system, and thermal management system, and their diagnosis using OBD. In this section, we will focus on the one-pedal driving feature in BEVs. The one-pedal driving feature is unique to some BEVs. This feature allows a driver to control the vehicle with only the accelerator pedal, manufacturer-specific. Depressing the pedal allows the vehicle to accelerate. Releasing the pedal partially slows the vehicle, and fully releasing the pedal brings the vehicle to a stop. The vehicle's electronic control module monitors the accelerator pedal position sensor and the vehicle's speed sensor to determine how much regenerative braking to apply. A scan tool can be connected to the data link connector, commonly known as DLC connector, to read the data located in the electronic control module, abbreviated as ECM. A scan tool can also be used to see how much pressure is applied to the accelerator pedal and whether the one-pedal driving system works properly. This data can be used to monitor and diagnose one-pedal driving. In this section, we will look at the instant start feature in BEVs. On some newer BEVs, there is no physical start push button or physical key to turn on for the vehicle to start. The driver has a key fob or phone app to turn the car on. When the driver places a foot on the brake pedal, the vehicle can shift into gear and move. Some BEVs use passive keyless entry. The passive keyless entry uses a radio signal to communicate between the key fob and the vehicle's computer. When the key fob is within range, the computer can unlock the doors and start the car with the foot pedal depressed. There are modules that monitor this signal to verify that the key fob is properly communicating with the vehicle. Some manufacturers have a phone app that can communicate with the vehicle and command the vehicle to start. If the modules detect a problem with the vehicle starting, the modules could generate a diagnostic trouble code, DTC. A technician can use this DTC to diagnose the problem. These codes can indicate various problems with the keyless entry control module, including electrical, software, or mechanical problems. Note that the type of modules that monitor the keyless entry in a vehicle could differ depending on the manufacturer. In this section, we will focus on the Pedestrian Alert System feature, abbreviated as PAS. So, what is a Pedestrian Alert System, PAS? It is a safety feature that is designed to make BEVs more noticeable to pedestrians, especially when the vehicle is moving quietly at low speeds, such as during parking or slow urban driving. Since BEVs tend to be quieter than traditional internal combustion engine vehicles, pedestrians, especially those with visual impairments, might not hear them approaching. PAS aims to address this potential safety concern by using sounds or signals to alert pedestrians to the vehicle's presence. PAS is a feature required for all BEVs sold in the U.S. since September 2021. This requirement is mandated by Federal Motor Vehicle Safety Standard, abbreviated as FMVSS, number 141. It helps prevent pedestrian accidents. Several different BEV pedestrian alert systems are available and function similarly. PAS uses sensors to detect when the vehicle travels below a certain speed, typically below 20 miles per hour. When this happens, the system emits a sound designed to be loud enough to be heard by pedestrians, but not so loud that it is a distraction to the driver or passengers. The sound that is emitted by a BEV PAS varies from system to system. Some systems use a simple beep or chirp, while others use more complex sounds that are designed to mimic the sound of a traditional car engine. The goal is to create a sound that is attention-grabbing but not startling. Depending on the manufacturer, the BEV PAS is monitored by a module in the vehicle. In this section, we will focus on the propulsion feature in BEVs. So, what is a propulsion system? This refers to the entire assembly that generates the driving force for the car. It encompasses everything from the battery storing the energy to the wheels that transmit that energy to the road. This includes the battery pack, the power electronics, DC to DC converter, inverter, the electric motor, the motor control unit, abbreviated as MCU, and the thermal management system, abbreviated as TMS. BEVs use a high-voltage battery and an electric powertrain or electric drive motor. The battery stores the energy that powers the motor, and the motor converts that energy into torque. Torque is the rotational force that turns the wheels. One of the key differences between BEVs and conventional vehicles is how they deliver power. BEVs have instant full power when the accelerator pedal is pushed. This is because the motor can deliver its maximum torque from the moment it starts turning. Conventional vehicles, on the other hand, need to build up to their maximum power. This is because the internal combustion engine needs to increase its revolutions per minute, abbreviated as RPM, before it can produce its maximum torque. The instant full power of BEVs is one of the things that makes them so efficient. Because BEVs don't need to build up to their maximum power, they can use less energy to accelerate. BEV modules use different types of sensors that monitor data. A diagnostic trouble code, abbreviated as DTC, can be generated if one of those sensors receives invalid data. In this section, we will focus on the thermal management system, abbreviated as TMS, feature in BEVs. So, what is a thermal management system, TMS? A TMS is a system that controls the temperature of the vehicle's battery, motor, and other components. Maintaining the correct temperature for these components ensures their performance, reliability, and longevity. The four main functions of a TMS in a BEV are to store heat, heat and cool the passenger compartment, discharge heat into the atmosphere, and thermal energy transfer. Let us now look at each function in detail. One of the functions of the TMS is to store heat. TMS stores heat in the battery pack to improve the range and performance of the BEV. The heat is stored in the battery pack when the vehicle is not in use and can also provide heat to the passenger compartment when the vehicle starts. The heat is stored in the battery pack in a variety of ways. Some BEVs use a liquid coolant to help maintain the battery pack's temperature. The excessive heat stored in the battery pack is then transferred to the passenger compartment using a heat pump or a series of fans. Storing heat in the battery pack can improve the range of the BEV in several ways. First, it can help to prevent the battery pack from overheating. Second, it can help to warm up the battery pack. Third, it can help to provide rapid cabin heating. Overall, storing heat in the battery pack is a valuable way to improve the range and performance of BEVs. Let us now look at another function of the TMS, to heat or cool the passenger compartment. The passenger compartment in a BEV can be heated in several ways, including a power electronics cooling system, the high-voltage battery pack, and waste heat from the propulsion system. The power electronics cooling system cools the electronic components in the BEV. The heat from the power electronics components can be used to heat the passenger compartment. In cold weather, the heat from the battery can be used to heat the passenger compartment for around 60 minutes. In some BEVs, the waste heat generated by the propulsion system can also be used to heat the passenger compartment. Overall, the specific methods used will depend on the make and model of the BEV. In this image, you will notice the different components of the TMS, including the e-motor and power electronics, the cabin, and the battery. The image also displays the battery's different operating ranges. The optimal range is the range where the battery performs best, as indicated in yellow. The limited operation range is the range where the battery can still operate, but it may not perform as well, as indicated in pink. The area of maximum temperature is the range where the battery temperature is too high and can cause damage, as indicated in blue. The e-motor and power electronics are components that convert electrical energy into mechanical energy. It is also responsible for controlling the speed of the vehicle. The e-motor and power electronics generate heat, which needs to be dissipated by the TMS. The motor and power electronics need to be kept at a safe temperature. Number 2 is the cabin. This also needs to be kept at a comfortable temperature. The heating system can be used to heat the cabin, and the cooling system can be used to cool the cabin. Number 3 indicates the battery. It is the source of energy for the BEV. It must be kept at a safe temperature to operate efficiently and prevent damage. The cooling system uses a liquid coolant to remove heat from the battery. Note that the cooling system is responsible for removing heat from the battery, the motor, and the power electronics. It uses a liquid coolant that circulates through the components and carries away the heat. The heating system is used to heat the battery when it is cold. It uses a coolant that circulates through the battery and absorbs heat from the surrounding space. It is important to keep all the components at an operable temperature to ensure the vehicle's long-term health. Some BEVs have a TMS that uses an outside condenser and radiator to discharge excessive heat into the atmosphere, known as atmosphere discharge. Atmosphere discharge is used when the TMS needs to remove a large amount of excessive heat from the battery pack. This can happen when the vehicle is driving in hot weather or when the battery pack is being charged quickly. Atmosphere discharge is a relatively efficient way to remove heat from the vehicle's battery pack. There are no diagnostic trouble codes, DTCs, specifically for atmosphere discharge in the TMS of a BEV. However, a few DTCs could be associated with problems in the TMS that could lead to atmosphere discharge. Thermal energy transfer is another function of the TMS. It helps keep the battery pack at a consistent temperature, improving its performance and longevity. There are a variety of methods of thermal energy transfer that can be used in a TMS. The methods are liquid cooling and heat pumps. The most common method of thermal energy transfer is liquid cooling. Liquid cooling, as illustrated by the blue lines in the diagram, uses coolant to dissipate heat between the different components of the TMS. The coolant circulates through a series of pipes or hoses and channels, absorbing heat from the battery pack and the motor and releasing the heat to the air, or a heat exchanger. Heat pumps, as depicted by the red lines in the diagram, work by reversing the natural flow of heat. They can take heat from the cooler outside air and transfer it to the warm air inside the passenger compartment, or they can take heat from the warm battery pack and transfer it to the outside air. Heat pumps are more efficient than liquid cooling, but are also more expensive. The thermal energy transfer methods used in BEVs TMS are constantly evolving. As new technologies become available, manufacturers are looking for ways to improve the efficiency and performance of their TMS. Let us now recap what we have covered in this lesson on the unique features of BEVs and their diagnosis using OBD. Some BEVs offer a unique driving experience with a single pedal that controls acceleration and braking, streamlining the process and enhancing efficiency. In terms of safety, BEVs are equipped with pedestrian alert systems. These systems emit audible sounds to warn pedestrians of the vehicle's presence, addressing concerns about the quiet nature of electric motors. The heart of BEVs lies in their battery and powertrain, working in harmony to provide the power needed for propulsion. High-voltage batteries serve a dual purpose. They store energy for movement and capture and store excess heat generated by the propulsion system. This stored heat is then repurposed to heat the passenger compartment. The thermal management system takes care of several vital functions. It serves as a heat reservoir, effectively manages the heating and cooling of the passenger compartment, maintains a balanced atmosphere within the vehicle, and optimizes the transfer of thermal energy between components, all contributing to the overall efficiency and performance of the vehicle. Thank you.